Okay, so today's lesson we're going to talk about additional methods to proving that two triangles are congruent to one another, and that is angle side angle, abbreviated with ASA, and angle angle side. Now we've already talked about in the prior section side side side, side angle side, and hypotenuse leg. So now we're adding two more methods here. So let's take a look and see how these work. So the angle side angle congruence postulate simply says that if two angles and the included side, so the side between them of a triangle, are congruent to two angles and the included side of the second, then the two triangles are congruent. And you see that represented pictorially here. So I have an angle, the side between, and a second angle congruent to that of another triangle. Therefore, triangle ABC is congruent to triangle DEF. Again, it's important in how you notate the congruent statement. Angle A refers to angle D because these are the two congruent, so they're listed here first in the same position or corresponding position. Then we move to angle B, which corresponds to E, and then C, which corresponds to F. Now, the angle-angle side congruence theorem tells us that if two angles and the non-included side, so you've got two angles followed by a side of any triangle, are congruent to the two angles and the corresponding non-included side of the second. So corresponding is the key word here of the second triangle, then the two are congruent. So again, we see that represented here, triangle ABC and DEF. I've got angle, angle, side, and the side again corresponds to EF here, so it follows angle, angle, side. So this would not work if, say, it was congruent to this side over here, because that would not be the corresponding side. So let's look at a simple proof, a short proof here, to show that two triangles are congruent. So I see my two triangles. Again, using a little color, I see that this leg is congruent to that. I see this angle is congruent to that angle, and this angle congruent there. So as I work around the triangle, I see this would be angle, angle, side. It's okay if you see it as side, angle, angle, because that can certainly just be reflected, and that's angle, angle, side. Same difference. So what they tell me first is that the given angle A is congruent to angle D, angle C is congruent to angle F, and segment BC is congruent to segment EF. So we're going to go ahead and list our information here. So the given typically comes first, so I have angle A is congruent to angle D, and I'll say again angle C is congruent to angle F. This was given. Then we also have segment BC is congruent to segment EF. That also was given. And then we have, essentially what we're asked to prove here, your proof statement is usually the last thing listed. ABC is congruent to triangle DEF. Why? Well, they told me angle, angle, side, and that's the method of proof, so this would be by angle, angle, side. So let's try another one. So we see X is the midpoint of VW and WZ. So X is between VY, so this piece here. And it tells me it's the midpoint, which means that VX, this piece right here, is congruent to this piece right here because X is in the middle. And it also tells me it's the midpoint of WZ. So again, it's the middle, so this piece, XZ, is the same as XW. Now, this one requires a little bit more thought. The given information here is I can say, let's say segment VX is congruent to segment V to X, so is Y to X. and that would be the definition of a midpoint. So because I have a segment VY and X is in the middle, V to X and Y to X is the definition of a midpoint. Now I also have the same thing going on here, and I could list that probably within the same thing. We'll just list it under here, number 1, segment ZX equals segment WX. Still with definition of a midpoint there, so we're just going to list that all in number 1. Now, what do we know? Well, I know that this angle here and this angle are vertical angles. So we'll say angle. I'm going to use 3 points to name it this time instead of just saying angle X, because angle X is unclear. I could be speaking of this side, I could be speaking of this side. So I'm going to say angle VXW is congruent to angle. So I went VXW, so I'm going to go YXZ. And why? Because these are vertical angles. Now what I've shown is that 2 sides and an angle, the included angle. So this triangle goes back to the prior section. So I actually have triangle, we'll say XYZ is congruent to. So I went XYZ, so I'm going to go XVW. So XYZ, XVW. And why? We just show that using the side, the included angle, the angle between, and then the side. So that is my SAS. And a pretty simple proof there showing that these 2 triangles are congruent. Let's look at another example. Can you prove that these triangles are congruent? Well, let's see. I see I have an angle here. This notation tells me it's also congruent to that angle. I have a second angle. The notation again tells me it's congruent there. And then I have this side is congruent to that side. So I have a triangle here, and then I have another triangle here, and I've shown an angle, side, angle, congruent to the angle, side, angle of the other. So this I certainly can, and that is by angle, side, angle. And we see this one down here, the information that I know. I have common angles, common angles, common angles. Now they do not share this side. Had they shared this side, I probably would have been able to prove that these 2 were congruent, but they do not. They have no side in common, and I don't know anything about their side. All I know is that the 3 angles are congruent. So if I were going to write this, that would be an angle, angle, angle. And AAA, AAA, is not a method of proof. It is, however, a method to prove similarity. These 2 triangles would be similar, but we'll talk about that in a later chapter. So these ones, using the methods we have, and we have 5 at this point, cannot be proved to be congruent. And we'll look at the final example here. I have an angle, second angle that corresponds, and then sides. So I have angle, angle, side, angle, angle, side. It is the corresponding side in both. So this would be a yes by angle, angle, side. So very similar to what we were doing yesterday, this is just added in 2 new additional methods. And here they are all listed here. So this chart right here might be something that you want to kind of earmark or write again in your notes, or make sure that you have this handy. These are the 5 methods that we have. These are the only 5 methods that there are in order to prove that 2 triangles are congruent. So we have the ones we learned yesterday, SSS, SAS, hypotenuse, leg, and then the new ones we've added, ASA and AAS. Now, another thing here that's commonly used in proofs, and it's most easily abbreviated by CPC-TC, and what that says is that corresponding parts of congruent triangles are congruent. So basically, if you have congruent triangles, the parts that match up are also congruent. That's what CPC-TC means. So if two triangles are congruent, then their corresponding parts must also be congruent. That's all it says. It's kind of a no-brainer, but this is the actual method for showing this in a proof. So let's take a look at a little bit more practice. So it asks us to state the third congruence that's needed to prove that triangle DEF is congruent to MNO using the given postulate or theorem given. So let's see. So I have DEMN triangle, or excuse me, angle M congruent to angle D. And they're asking me to use SAS. Well, this is probably most easily done by drawing a picture. So I'm going to go ahead and take a little triangle tool. These are not necessarily right triangles. And actually, I'm sorry, they've got these over here, so that does help. Let's see, is this for this one? DEF, MNO. Perfect. So we'll say DE is congruent to MN. Angle M is congruent to angle D. And since I want to show this with side angle side, I'm also going to need to prove this side, this angle, so I need to include that angle. So it would have to be this side. So we'll say that DF, D to F is congruent to MO. And that justifies that these two triangles would be congruent using the side angle side theorem. Let's look at a couple more. So this one says that F to E is congruent to ON, and that angle F is congruent to angle O. So using the angle side, so I want angle side, so I need to show that this angle D is congruent to the corresponding angle M. So angle side. We'll erase that and set up the last one here. And this one says DF is congruent to MO, and angle F is congruent to angle O using angle side angle. So, well, here's an angle over here, but if I went angle side angle, this would be like angle side, or angle, and I'd have this side, and then the side here, and then an angle. So in order to make it angle side angle, I need to go back to this angle. That way this is the included side. See, the side is between the two angles. So that would be angle D and angle M. So that proves that these two triangles are congruent using the angle side angle postulate. And can we prove these are congruent? So let's see what we know. I have angle H to angle L. I have side or segment KH to GL. Then I have a 90-degree angle right here. Well, what I do know is if this is 90 degrees and this is a solid line, or just a line here, and this one branches off of it, then this must also be 90 degrees. So if this were to rotate, say, this way, it would fall down and lay just like that. So yes, these two, so now I know that this angle is congruent to this angle, so I can prove that these two are by angle side. And this one I have a common side, or congruent sides, an angle, and then I have this side in common. So what can I prove about this triangle? I know that a side angle, or angle side. So you can always list out what you know. So I can say side angle, or if I flip that, I go the other way, it's ASS. These are the same thing, just written forwards or backwards. And this one's always easy to remember because it spells a bad word. And this is one of the ones that does not work. If you go back up above, SSA or ASS is not one of your 5. And just if you want to make a side note over here, the two that do not work are ASS and AAA. These are the two that do not prove congruence. Any other combination of A's and S here will prove congruence, but ASS and AAA do not. So we'll just notate that again, do not prove. So this one would be a no. And if we go on to the next one, I have an angle, another, and I have this side they have in common. So it must be equal to itself. We've talked about that before. That's the reflexive property. So I have angle, side, angle. That is one of the five. So this is a yes by angle, side, angle. Now these ones are always a little bit more difficult because we have to recall some of our prior learning. Remember, this notation here tells me that these two lines are parallel. So what I actually have is an angle here that corresponds to an angle here. Remember, these are alternate interior angles, and those are congruent. I also have the same thing going on here. These are also alternate interior angles and congruent. And then they don't have any common sides, so I don't know anything about that. And I do know, though, that these are vertical angles. So I know that these two are congruent. So what I can prove is that I have angle, angle, angle. And as I see back over here where I just made my little note, this is not a method for proving congruence. So might they be congruent? They certainly could be, but I'm not able to prove it with the information I'm given. So this is a no. And the last one here. Tell whether you can use the given information to determine whether triangle JRM, let's go ahead and label these, JRM is congruent to XYZ. So I've listed them in the corresponding order, JRM, XYZ. And now I'm going to go ahead and set up these different scenarios. So I have JM, J to M, is the same as X to Z. Angle M is the same as angle Z. And angle R is congruent to angle Y. So again, as I notate this, boom, 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 I have angle, angle, side, which is one method of proof to prove that two triangles are congruent. So this would be a yes by angle, angle, side. That's all that we're really asking for when we say explain your reasoning, is what method of proof do you have to justify that the two are congruent. And right now, remember, we have 5 of them. Side, 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 angle, side, hypotenuse, leg, angle, side, angle, and angle, angle, side. And then we'll set up the last part here. J to M is congruent to X to Z. Segment JR is congruent to segment XY. And angle J is congruent to angle X. So again, it's pretty easy with a picture. I have a side, the angle included, the included angle, it's between the two sides, just as if you would write it, angle, side, side, angle, side. I have a side, the angle between them, just like the A's between the S's, and then the side. So this again is another yes by side, angle, side. Okay, so try the worksheet and we'll get a little bit more practice at it.